Welcome to today's Explainer. I am absolutely thrilled you're here because today we're going to run a system diagnostic on what is arguably the most complex, fascinating, and frankly, glitchy information processing system in the known universe. I'm talking about the human brain. We literally rely on it for every single thing we do. And yet, as we're about to see, the way it stores and retrieves data is far, far from perfect.
So let's just jump right in with a question. How accurate is your memory system really? Because, most of us walk around with this absolute certainty that we remember our past perfectly. We kind of think of our memory as a video camera, just perfectly recording events exactly as they happen. But I'm here to tell you that absolute certainty, it's an illusion. Your memory is not a perfect recording device. And I can actually prove it to you right now.
Take a look at this classic visual test based on a study by Nickerson and Adams. Which one of these is the real U.S. penny? If you're struggling, don't worry, you're definitely not alone. The researchers found that very few participants could actually identify the correct one. But why? I mean, we see pennies all the time, right? Well, it turns out we don't actually bother to encode their specific features into our memory system. We just encode exactly enough to know it's a penny. So this proves right out of the gate that mere exposure does not equal a perfect memory. So, here is our system directory for today's explainer. 1. Defining the system. 2. Memory architecture. 3. Core processes. 4. Optimization hacks. And 5. System glitches. Starting with number 1. Defining the system, memory, and cognition. At its core, memory is defined simply as the ability to store and retrieve information over time. But the absolutely crucial point here is that second half. Memory is an active, constructive process. When you remember something, you're not just hitting play on a recorded video in your head. You're actually reconstructing that event on the fly. You're actively interpreting the information. And because of this, what you pull up is literally never an exact replica of what originally happened. Okay, moving to part 2, memory architecture, types, and stages. Our brain's memory system is broadly divided into two main drives, explicit and implicit memory. Think of explicit memory as the files you consciously click on and open. It requires your active awareness to retrieve, like remembering what you had for dinner last night or the capital of France. Implicit memory, on the other hand, is like your background operating system. It influences your behavior and runs programs without you even realizing it, requiring absolutely zero conscious awareness. Let's walk through these branches a bit. Under explicit memory, we've got semantic memory, which is your database of facts and general knowledge. And then we have episodic memory, which stores your personally experienced events, basically the episodes of your life. Now, looking over at implicit memory, we find procedural memory, which handles your motor and cognitive skills. Think riding a bike. There's also priming, where recent experiences enhance how you identify objects or words. And finally, learning through classical conditioning, like associating a specific sound with an action. The crazy part, all of this implicit stuff just runs automatically. All this architecture builds into a very specific data pipeline, famously known as the Atkinson-Shiffrin model. Information comes in as sensory input and hits your sensory memory buffer. Now, this only lasts a tiny, tiny fraction of a second. If you actually pay attention, it moves into short-term memory, also known as working memory. But here, you have to actively rehearse it, or again, it's gone. Finally, through a process called encoding, it gets saved into long-term memory. But notice how information can drop off. At every single stage, unattended or unrehearsed information is just lost forever. Which brings us to number 3, core processes, encoding, storage, and retrieval. For any piece of data to actually stick and be remembered successfully, it has to pass through all 3 of these sequential steps without a single error. First up is encoding, which is placing the things we experience into memory. Next is storage, which is maintaining that data over time. And finally, retrieval, accessing that stored data when you actually need it. If you forget someone's name right after meeting them, well, that's usually an encoding failure. You never actually saved the file. But if you have a word on the tip of your tongue and you just can't say it, that's a retrieval failure. You have the file, you just can't get it to open.
Let's look at number 4, optimization hacks, upgrading your memory.
The good news is we can actively optimize our memory using some scientifically proven hacks. First, elaborative encoding. Don't just repeat facts, process them in a meaningful way. Connect new info to things you already know. Second, the self-reference effect. We remember things incredibly well if we link the material to our own lives and personal experiences, basically make it about you. And third, the spacing effect. Please do not cram. Information is learned far, far better when you study in shorter periods, spaced out over time. Another massive optimization tool is realizing that context really matters. Whether it's context-dependent or state-dependent retrieval, you will pull data out of your long-term memory much faster if you're in the exact same physical situation or the exact same psychological state as you are when you first encoded the data. Actually, studying for a test in a quiet room that feels like a testing center primes your brain to remember better when you're sitting in the real exam. And finally, number 5, system glitches, errors, biases, and distortions.
All right, time for these system warnings. Our cognitive processing is highly vulnerable to biases, literal glitches in the mind's code. For example, source monitoring errors. This happens when we remember a fact but completely forget where we heard it, which makes it really hard to judge if the information is actually reliable. Then there's the misinformation effect, where our memories are actually altered by misleading information we hear after an event. Add to that confirmation bias, where we only remember information that validates our existing beliefs. Throw in our tendency toward overconfidence and functional fixedness, where we get stuck seeing things only one way, and you can see how easily our internal reality gets distorted.
A major reason these glitches happen is because of something called schemas. Schemas are patterns of knowledge in our long-term memory that help us organize information. Think of them like mental templates. We have schemas for how a restaurant works or what a typical dog looks like. Now, they are super helpful for processing the world quickly, but if we over-rely on them, our brain will literally fill in the gaps with what it thinks should be there, causing us to falsely remember things that never actually happened. And these glitches also mess with how we judge the world around us, usually through mental shortcuts called heuristics. The representativeness heuristic is when we make a judgment based on our expectations or prototypes, basically judging a book by its cover. The availability heuristic, on the other hand, is judging the likelihood of an event based purely on how easily it comes to mind. Like if you watch a lot of Shark Week, you might think shark attacks are incredibly common just because those images are highly available in your memory. Misapplying these shortcuts leads to massive flaws in our judgment. Which brings us to a final thought I want to leave you with today. We've seen the hardware, the software, and the glitches. We know that every time we recall a memory, we are reconstructing it, totally vulnerable to biases, schemas, and heuristics. So, if memory is entirely a reconstruction, how much of your past is actually accurate, and how much is simply a story you've told yourself over and over again? It is a pretty fascinating, lingering thought to walk away with. Thank you so much for joining me for this explainer on the human memory system. Keep learning and always keep questioning what you know.